Hello, my name is Mohammad Ihtisham Yusuf, and my group members are Charanjit Kaur and Gurpreet Singh. So, uh, I'll be presenting presentations and I have 4 slides. Graphic analysis for this is the variables with numerical values are known as numeric values, might be continuous or discrete. The number of children that family has is an example of that variable since it has a finite number of values. Continuous numeric variables like height, weight, etc. are variables that can have an endless number of different values. The analysis provides the cluster plot for the batteries, power that represents that in range of 500 to 2000. How many batteries have strong battery durability power? And another analysis provides the linear graph, which shows how many phones have 4G connections and how many has not. So the graph shows the data of set 4G phones and non-4G phones has equal values, which means both phones are thousand. There's 1,000 pieces for the handset. So this is the statistic analysis for this. As this is the method called a hypothesis test is used to investigate a population parameter. It serves as a test to see if the hypothesis is correct or not, as seen in the picture. A comparison between the observed data and what would be anticipated if the hypothesis was true, if the foundation of the hypothesis test. During the test, data must be gathered, examined, and a conclusion on the hypothesis must be reached. To ascertain if the observed data is in line with hypothesis or hypothesis test is utilized, during the test, data must be gathered, examined, and a conclusion on the hypothesis must be finalized and reached. A statistical test such as a t-test, chi-test, or ANOVA is used to assess the data. A crucial value is then used to compare the test against. So this figure describes the results for the hypothesis test, that is enough data to reject the null hypothesis and draw the conclusion that there is a significant difference between mean scores of the groups at a significance level of 5%. So the last slide for my part is simple linear regression, and that's called statistical technique called simple linear regression is used to examine the connection between two numeric variables. If it is employed to assess the degree to which the two variables are related and to forecast the value of one variable in light for the value of the other. The selection for the two variables to be utilized in first step in carrying out straightforward linear regression analysis. The research question being addressed and the data at the hand should be taken into consideration while choosing the variables. The next step is to examine the data after choosing the two variables. To see the link between the two variables, the data may be shown on the scatter plot. You can see the plot on the right hand side as well. That data may be fitted using a linear regression model if the data points follow a linear pattern. The regression coefficients must then be calculated. So that's all from my side, and then I will like to ask. You're mute.
Yes, thanks, Intisham. Now I am going to present slide 6. A continuous dependent variable may be predicted using simple linear regression, a statistical method using only one independent variable. It is the most fundamental kind of linear regression, which models the connection between two variables by fitting a linear equation to the data that has been collected. Y is the dependent variable, M is the line slope, X is the independent variable, and B is the intercept, the value of X when Y is equal to 0, making up the equation Y is equal to MX plus B. Finding the best fitting line of depicts the connection between two variables is the aim of linear regression. Assumptions of simple linear regression models are as follows. Connection. The dependent and independent variable have linear relationship. Error independence. The model mistakes are unrelated to one another. Error normality. The model's errors are normally distributed. Common violations of these assumptions include nonlinearity. The independent and dependent variables have a systematically connection. Autocorrelation. The model mistakes are not independent of one another due to autocorrelation. Non-normality. The errors in the model are not normally distributed, which is known as non-normality. Multicorrelation. There is a strong correlation between independent variables. In the next slide, the choice of the variables included in the model determines how well a multiple linear regression study performs. The correlation between the independent variables and the dependent variables, as well as the multi-correlation between the independent variables, should be taken into consideration while choosing the variables. Finding the independent variables that are highly correlated with dependent variables is the legal goal of the variable selection procedure. The correlation conflicts between each independent and dependent variable may be calculated to do this. The model should only include the variables having greatest correlation conflicts. Check to see if the independent variables are multicollinear. The variance inflation factors VIF for each independent variable may be calculated to do this. The VIF for each independent variable should be less than 10. The variable should be taken out of model if the VIF is higher than 10. After choosing the variable, the multiple linear regression model was constructed. The R-square value, which reflects how much variance in the dependent variable is explained by the independent variables, may be used to assess the model's performance. The performance of the models improve R-square increases. In the 8th slide, a model called multilinear regression is used to forecast a numerical value given a number of independent factors. Presiding the value of single independent variable is an extension of simple linear regression. The dependent variable of independent variable are thought to related linear by the model. Additionally, a proposed that there is a multicollinear among the variables and the independent variables do not have a strong correlation with one another. Additionally, models make assumption that its mistake are regularly distributed and unrelated to one another. Last but not the least, the model makes an assumption that errors are unaffected by the values of independent variables. Normality. A normal distribution of models residual is assumed to exist. The estimate of the regression coefficient may be based if the assumptions is broken. Robust standard errors and transformation of the dependent and independent variables are frequent solution to the problem. Linearity. The idea that the connection between dependent and independent variables is the linear is known as linearity. Inaccurate statistical test and conflict estimation can result from breaking the premises. Using polynomial and spline regression of changing the depend are common solution to this. Now, Charan is going to start the next slide.
Hi friends, my name is Charanjit Kaur and my student ID is 20173161. I'm not well and I'm having fever right now. It's been 7 days I'm actually suffering with, but still I'm actually trying to, because it's just been this is the last day we have to submit the submission. As we are talking about discussing and elaborating about the statistics for decision making, I'm going to speak about slides 9, 10, 11, and 12 to elaborate about the models. Measurements, prediction, accuracy may be used to access the performance of the simple linear regression. And by doing this process, roof mean squared error and coefficient of determination helps in completing the task. Moving to R2, measures is to how much of the variance in the data is explained by the model, whereas in the RMSE measure, it shows how distant the model's predictions are from the real values. In this case, the model performance better the lower the RMSE and if the higher the R2. And the similar criteria may be used to access the efficiency of the multiple linear regression. Further, the adjusted R2 may be used to gauge how much of the variation in the data is explained by the model, and the RMSE and R2 can be used how accurate the model's predictions are. So the better model performance, the lower could be RMSE and the higher will be the R2 and adjusted. So now flipping to slide number 10. I'm describing about the significance of the contribution of model 1. A significance level of O.05 indicates that there is a O.05 chance that the independent variable will not significantly affect the basis linear regression model, which is the null hypothesis. And by comparing the independent variables regression coefficient to 0, we can use the f-test to examine if it significantly influences the results, as well as we can reject the null hypothesis and final the independent variable significantly affects the basis linear regression model if that statistics is higher than the critical value, which is established by the threshold of significance. I'm flipping to slide number 11, which is about the contribution of model 2. The multiple linear regression is model 2. Multiple independent variation regression is the null hypothesis for the test. The other possibility is that the multiple linear regression, what model 2 does significantly benefit from the independent variables, going to the regression of coefficiently of the independence variables may be compared to the hypothesis value of O using the test in order to evaluate the hypothesis. In this case, the hypothesis may be disapproved and it can be said that the independent variables discontribute to multiple linear regression if the p-value of the test is less than O.05. Finally, it concludes that after the examination of all the details of above question and answers, that for prediction analysis, these methods are extremely useful to be used in a big database and without any programming or code based things. Some formulas can be useful to analyze the record that have lots of values and variables. And this studies to the conclusion that there is a significant correlation between the two variables, suggesting that there is a probability it can use connection between them, and the references taken is on the other slides. That's all, and thank you all my group members in completing the assessment and the teachers to help me all through the semesters. Thank you all. Good day and take care.